Example 8. How long will it take money to triple if it is invested at 5% compounded daily? Assume a 365-day year. Okay. In example 5, this was part G. Let me write that on here. All right. And we discussed in example 5G that this is a compound interest problem. Okay, so I'm going to go ahead and write down the compound interest formula. Okay. But let's revisit why this is a compound interest problem. The strange thing about this problem is that you don't have any dollar amounts appearing, okay? It just says that, you have money and you're investing it and you're trying to figure out how long it's going to take the money to triple if it's invested at under these conditions, okay? So the reason that this one is compound interest, first of all, you see the phrase compounded daily. That eliminates simple interest, okay? The reason that this is compound interest and not the future value of an annuity is if you read this carefully, it's kind of implied that you're taking some amount of money, we don't know specifically how much, but you're taking this one lump sum and investing it, and you're trying to figure out how long it's going to take that one lump sum to triple. So you're saving money, you're investing it, and it's implied that it is a one lump sum here. So that makes it a compound interest problem. All right, let's go ahead and figure out the values of the variables, okay? First thing to notice here, how long will it take? You're actually solving for time, okay? How long is it going to take my money to triple, okay? Notice in this formula, time is in the exponent. It's in the power. That is going to be pretty complicated to solve for, okay? This is going to be our first example with these more complicated formulas. Remember, solving for time is pretty straightforward if you're doing simple interest, but beyond that, time is going to end up in your exponent for pretty much every other formula in this chapter. And to get if you're solving for a variable that's in the power, you're going to have to get logarithms involved, okay? So you should have had logarithms in college algebra. If you haven't seen them before, I'm treating this as like you've never seen them before, so you'll be able to pick it up. We won't go into extensive details with logarithms, but I will show you how to work the problem, how to solve for time, okay? All right, so we're solving for time. It's going to be complicated because time's in the exponent. All right, interest rate is 5%, so that's going to be 0.05. We're compounding daily, so is 365. Okay, and then the remaining variables are P and A. Okay, and like I said, it's a little tricky here because they don't tell you how much money you're investing, and it doesn't actually matter how much you invest, okay? All you need to do, since they don't tell you, is make up a number for P. It's gonna work, I promise, okay? I'm just gonna pick a random number, okay? I'm gonna pick $100, okay? You can pick anything you want. You could pick $5,000 if you wanted to, okay? So if I invest $100, I want to know when my money's going to triple, so you just multiply the P value by 3 to get the A value, okay? So the A value is going to be 300, okay? If you had chosen P as 5,000, for example, you would triple that and have an A value of 15,000. It is going to work out, I promise, and you'll see that once we start working the problem, okay? So these are your variables. We're going to go ahead and plug in, and then we'll start solving for time, okay? So if I plug this stuff in, I'm going to get 300 is equal to 100 times 1 plus 0.05 divided by 365 raised to the 365t power, okay? And our goal now is to solve this for t, okay? All right, like I said, it's going to involve logarithms, okay? So let me give you a little intro about that, okay? If you look at your calculator, okay, your calculator is going to have two logarithm keys on it. You're going to see an LOG button and you're going to see an LN. Basically, the difference is log is what we call a base 10 logarithm, and LN stands for natural log. It is a base E logarithm. E is the number. It's about 2.71. It's a number like pi. We're going to actually talk we're going to talk more about it a little bit later. But ln is a base E logarithm. That's the difference between the two. You can actually have any positive number other than 1 be a base for your logarithm. So there's actually tons and tons and tons of logarithms. These two are the most popular types of logarithms. So that's why they actually have physical keys on your calculator. Depending on your calculator may or may not do other bases. You would just have to dig inside the menus for them. But for the purposes of this class, we're only going to use ln, the natural log. Don't even worry about using log. We can accomplish everything we need to do with using natural log. So that's what we're going to do. Okay, and like I said, if you haven't worked with logarithms before, I will walk you through this process. We're going to use it every time we solve for time, and time is trapped in the exponent. Okay. All right, so logarithms are going to help us because they are going to bring the power out of, or they're going to bring the t out of the exponent. Okay, that's why we need them. Okay, logarithms help us get the variable out of the exponent. Okay, so in order to solve this for time, because I've got it set up, okay, the first thing you're always going to want to do, okay, is you're going to want to isolate the exponential piece. This is something called an exponential equation, okay? It's got an equal sign, and the variable is in the exponent. So this is an exponential equation. So like I said, the first thing you're going to want to do is isolate the thing that has the variable, okay? Notice, this 100 is not raised to the 365t, okay? It's not in parentheses. Only this quantity that's in parentheses is raised to this power, okay? This stuff is attached to this power. You can't separate the two. So our first goal is going to be to isolate this guy because that's the part that contains the t, okay? And we can't separate any of this yet, okay? So like I said, 100 is multiplied by this quantity, okay? We need to isolate this thing in the box, so we're going to get rid of the 100. Since the stuff in the box is multiplied by 100, we can undo that by dividing by 100, okay? Whatever you do to one side, you have to do to the other, okay? So that's going to leave us with 300 divided by 100 is 3, and then the 100s would cancel right here and just leave us with the quantity in parentheses raised to the power. Okay, so now this thing in the box is isolated. Okay, you could, and I'm sure some of you guys are wondering, you know, can I go ahead and do out or work out and get a number for what's in parentheses? You can. It's just gonna have, you're gonna have to, it's gonna be some crazy decimal and you're gonna have to keep writing all the digits. So I wouldn't worry with that. Okay, you can, but you don't have to. It's probably easier to just keep writing this. Okay, all right, now that you've got this guy isolated, okay, you've got to bring the t out of the exponent, okay? And like I said, logarithms are what help us bring the variable out of the exponent. So what we're going to do is we're going to take the natural log of both sides, okay? Whatever you do to one side, you have to do to the other, okay? So natural log of 3 is going to be equal to the natural log of this quantity, okay? So that's what we got, okay? So now let's investigate this. There's a couple things I want to say. First of all, logarithms do something to a number, okay? Like this side is no longer 3. It's the natural log of 3. If you put that in a calculator, the left side has become some nasty decimal. Watch. Natural log of 3, ugly, ugly answer, okay? So that's the left side. No longer 3. It's this 1.09 blah, blah, blah number, okay? The other thing I want to point out, logarithms go on the left, not on the right. If you had written 3ln instead, that doesn't make any sense. Okay, so two things you got to realize, like I said, logarithms do something to numbers or to quantities. It changes them. This is no longer 3, it's a nasty decimal, and the logarithms have to go on the left. Okay, so why does this help you? Well, I said this is how we're going to get the t out of the exponent. Okay, there is a property of logarithms, okay, that if you have the logarithm of something to a power, the power can come down in front. Okay, you have to have the logarithm of something to a power in order to do that. So one more time, if you have the logarithm of something to a power, the power can come down in front. So that's why we had to take the logarithm, so that we could bring down the power. If you did not have the logarithm there, you can't bring down the power. The logarithm has to be present in order to do that. So the right side is now going to become, the power is going to come down, so 365 times t times the natural log of this stuff. Okay, the left side has not changed, it's still the natural log of 3. Okay, so that leaves us here. Okay, t is now out of the power, so it's a lot easier to solve for it. Okay, in the next step, okay, this is a number, it's some nasty decimal, I've already showed you that. Okay, and then this natural log of 1 plus 0.05 divided by 365, if you punch that in the calculator, also a nasty decimal. Okay, but just a number. Okay, so we can divide off this logarithm to get the t value. Okay, now if you think back to what I told you on page 5, let me pull it up really quick. Okay, we talked about this and I said it may not make a lot of sense at this point, but when you actually do the first example, it'll make more sense. Okay, at the bottom of page 5, we discussed this statement. Okay, when you are solving for time, okay, you don't actually solve for time, you solve for m times t. So if the compounding is monthly, you stop and solve for 12t. If it's quarterly, you're going to stop and solve for 4t. If it's weekly, you're going to solve for 52t. So if you apply that logic here, okay, we're going to be solving for 365t, not just t. Okay, I will explain why a little bit later. Okay, so you're solving for this thing in the box. This is just a number. This is just a number. You want this guy isolated. So since you're multiplying this by this, you're going to have to divide. The opposite of multiplying is dividing. You're going to have to divide off this logarithm. Okay, whatever you do to one side, you're going to have to do to the other. So when you do that, that's going to leave us with this. Okay, 365t is equal to the natural log of 3 divided by the natural log of 1 plus 0.05 divided by 365. Okay, take a minute and make sure you understand that. Okay, just a number. To isolate this guy, I've got to divide both sides by this quantity. Okay, all right, so now what we're going to do is this is actually going to be a number. We can punch it into our calculator. Okay, so let me grab my calculator and let's punch this in. Okay, this is going to, oops, that was loud. This is going to give us, because we're solving for 365t, not just for t. Okay, and I'll show you why as soon as we get this number. All right, so we're going to do natural log of 3 divided by natural log of 1 plus 0.05 divided by 365. Okay, so that's how you would enter it in. Okay, hit the button and you're going to get this ugly decimal. Okay, and now we're going to talk about how to interpret the answer. Okay, also on page 5, when we had that little blurb about solving for time, let me grab it again. Okay, not only do you have to solve for m times t, but once you get that value, remember, you have to round up to the next whole number to ensure that you're going to have enough time to accomplish what you're doing, okay? So if we go back and look at this decimal, okay, we need to round this up to the next whole number, okay? Now, after the decimal point, there is a 4. So typically, this should stay 8,020, but for time, you're always, always, always rounding up no matter what, okay? So this is good. This right side is going to round up to 8,021, okay? If this had been a 0.5 or a 0.6 or a 0.7, it would still round up to 8,021, okay? So basically, after the decimal point, no matter if you have a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, you would round up to 8,021, okay? Left side is still 365t. How do we interpret our answer, okay? Well, 365 in front of the t is indicating that we're thinking in terms of days. So it is going to take us 8,021 days to triple our money. Okay? That's what this means. Okay? Had there been a 12T in front instead of a 365T, that means it would have taken that many months. Okay, so that's how this works. Now, if you're like me, I don't want to sit here and count 8,021 days. So I am going to convert this answer into years in leftover days. Okay. When you go back and read the question, it is not specified how you're supposed to state the answer. So you need to be careful with this in MyMathLab. Are they asking you for the total number of days? If they are, you would write 8,021 and move on. Or are they going to ask you for years in leftover days? Okay. So what I'm going to do is I'm going to go ahead, because I'm going to go ahead and take actually, I'm going to go up here and do it so we don't get confused. I'm going to take the 8,021 and I'm going to divide by 365 because there are 365 days in a year. Okay, that's what we're assuming here. Okay, so I'm going to take, the reason I didn't do it down here was because you needed to round up time. So that's why I didn't do it here. Okay, so we're going to take 8,021 divided by 365. And you're going to get this decimal. Notice this 21 point. This indicates 21 whole years and then some. This number is very close to 22. Okay, so it's going to take us almost 22 years to triple the money. Okay, but we're going to be specific here and write it as years and leftover days. Okay, so I'm going to put this decimal on here just for your records here. So this is what I get if I do the division. Okay, so this is indicating so far that we've got 21 whole years. Okay, but this decimal part we've got to convert to leftover days. Okay, so what we're going to do, since we know that we've got 21 whole years, we're going to calculate the number of days in 21 years. Okay, so we're going to take 21 and multiply by 365. Okay, so that means 21 years is 7,665 days. Okay, and then we know the total amount of time it's going to take for our money to triple is 8,021. We're going to subtract out the number of days in 21 years. Okay, and then that is going to give us the number of days remaining. Okay, so which is 356. Okay, so it's going to take us 21 years and 356 days, which is so close to 22 years to triple our money. Okay, so if MyMathLab were to ask you how many days it would take to triple your money, this would be your answer. Or if it asked you how long is it going to take in years and leftover days to triple your money, you would write this answer. Okay, so or 21 years, 365 days. Okay, so that's the end of this problem. Okay, it is obviously pretty complex solving for time. Okay, but we will do more examples to make sure you get the hang of this, okay? And you're also going to have to solve for time with the future value of an annuity formula, okay? But it is going to follow a lot of the same steps, okay? So let's do another example.